All right, here's an interesting example. In this one, we have sine of t popping up twice. In one instance, it's squared, and in the other instance, it's to the power 1. In this instance, it's a little bit difficult to just isolate sine of t using familiar sort of adding, subtracting, canceling, that kind of thing. But what we can do here is notice that this is essentially in the format of a quadratic. So you may remember near the beginning of the semester when we were solving equations, we would occasionally encounter something which is in what we call quadratic form, and we can apply this idea of u substitution. So what I'm going to do here is say, let's let u equal sine of t, and I'm going to substitute in u in place of sine of t. So that would give me the equation 2 times u squared minus 5u plus 3 equals 0. And now, this is just a little bit easier to look at. With one variable, we're going to go ahead and factor this. You could have factored the original with the signs in it if you wanted to. There's no reason you have to do the substitution, but the substitution is a useful tool. So now we're going to try to factor this. It's going to have to be 2u and u, and then if you figure out, if you kind of do some trial and error or reasoning here, you can figure out this is going to be 2u minus 3, and this is going to be u minus 1. So that it multiplies up to 3, but then we have negative 3 and negative 2 adding up to negative 5. So here we have two possible solutions. U is going to be 3/2, or u is going to be 1. All right, so that means since u is equal to sine of t, we have two possibilities. Sine of t equals 3/2, or sine of t equals 1. Well, sine of t equals 3/2, that's actually impossible, right? Because 3/2 is 1.5 is greater than 1. And the sine function only gives us outputs in the range from -1 to +1. So sine of t equals 3/2 has no solution. If you try to draw that out on the circle, you'd go like this, and then you'd find 1.5 on the y-axis and try to put your horizontal line there, and you discover that that does not intersect the circle at all. So there's no solution from that possibility. So no solution from that one, but there might be a solution from this one, right? We have the second possibility over here. Sine of t equals 1, that definitely has a solution, because 1 occurs right up here at the top of the circle, right there. And so there is an angle that terminates right there, and that would be t equals pi over 2. And that is my solution to this equation. That's the only solution in the interval from 0 to 2 pi. All right, so let's do one more, which is kind of similar to this. Let's start with sine squared t equals 2 times cosine of t plus 2. Okay, kind of similar to that last one in that we have a trig function squared, sine squared, and we have another trig function which is not squared, which is in this case is cosine. So this is a little weird because these are not in agreement with one another, right? In the first example, they were both sine, and so we could do a u substitution with u equals sine, and then we have eliminated all the trig functions. But in this case, no such u substitution is available because one of them is cosine and one of them is sine, unless we apply a trigonometric identity to put one of these in terms of the other. So if we take sine squared, it's easy to put sine squared in terms of cosine. Because sine squared is 1 minus cosine squared via the Pythagorean identity. This is one of the reasons that identities are useful. It allows us to take expressions involving more than one trig function and put them in terms of a single trig function by doing some substitutions. And then we can say, let u equal that trig function, and then reduce a trigonometric equation to an algebraic equation via a substitution like this. And that's one of the values of trig identities, okay, to allow us to be able to do something like this. So now we have this algebraic equation. Let's gather everything on the right-hand side. I'm going to add the u squared back over. I've got plus 2u, and then I had u. I'm going to subtract 1. So I had 2, I subtract 1, and I get plus 1. This is just 0 equals u plus 1 squared. So there's only one solution here, u equals -1. So if u is cosine of t equals -1 is what we have to solve. And that is going to occur when the x-coordinate is -1, which of course happens right over here. And so the solution to that is going to be t equals pi. And in the interval 0 to 2 pi, that's the only solution.